Okay, here's a tutorial to go along with your slideshow from week 2. So from our website, under our schedule, week 2, we're going to be going through conversions and assignment operators. So if we open up this PowerPoint right here, we're going to be coding and going through this lesson. Okay, learning objectives here is to identify when data type conversions occur automatically. Use explicit casting to force conversion between compatible types. Recognize when promotion occurs and does not occur in expressions. Identify and resolve issues with integer division. And be familiar with shorthand operators commonly used in expressions. Alright, variable data types. Recall, every variable has a type. This is a type of string, but we have numbers such as integers, or true and false statements such as booleans, but this is a type. Once created, a variable can only store data of that type it was created for, or data that is compatible with that type. If we have here what we have identified a variable as type string, and we're trying to put in here an integer, it's not going to be allowed. It's not going to like that. Let's start an example here that we can flip back and forth with so I can code alongside this. I have a project called week 2 here. I'm going to put a class inside there for today's lecture called Data Conversions and Assignment Operators. Remember, spacing is not allowed, so we want to do camel casing to identify different words. I'm going to get my main method in there, and I'm going to start with that. Okay, it started trying, it made a suggestion of trying to store an integer into a string. So we had what was called string quote, and we tried to put 1,000 in there, and it did not like that. If we hover over there, it's going to tell us change type of quote to int. So this string will not accept that integer as a value. It's not allowed. However, we can, we can convert this. In this particular case, on the right hand side, we could do integer.toString and then put in the parameters 1000, and then that is acceptable into the string variable of quote. So let's look at how that works. So that one is not okay, but if I were to say, okay, integer.toString, and inside the parameters I put 1,000 there, it looks as though it's going to be okay. Let's do a print line just to make sure. Quote comes out as 1,000. Okay, so it does work if you cast it as such. Relative data sizes. Smaller data types can be stored in larger types without the risk of losing data. Just because the amount of information will fit within a larger data type. So a byte will fit into a short will fit into an int, and an int will fit into a long. Same thing as a float will go into a double. However, you do risk losing information if you went backwards. We're trying to put like an integer value into a short. We'll give you an example of how you could lose some value here soon. So here's an example. So we have this a widening conversions. If the type of variable is wider than the type of value being assigned, the assignment conversion automatically occurs. So it will be fine, and it will automatically widen that conversion, because if we have an int going into a long, it is going to widen that conversion, just as if that long going into a double, it will allow that extra information to go in there. So it works directionally that way just fine. So let's test that out. So we have int big number, and we're going to say it didn't even have a value. no, int small number, sorry. And we had it was okay, and we're putting it long, big. Okay, so far everything's going fine. That conversion works okay. And then okay, everything seems to work okay. So far so good. I just want to see what this printout will be for big decimal. So big decimal does take that and adds in there a 0 because it is a decimal point. So this widening conversion works just fine. These are some automatic assignments. So if you follow the green arrows, these types of data will automatically fit into the other ones. A character will go into an int as well as a double and a long. An int can go into a long and a double. An int cannot go into a string or a boolean, etc. So green arrows represent valid automatic assignments. Now narrowing conversions is when we take a value and put it into something that would not hold as much of that. So if the type of variable is narrower than the type of value being assigned, the assignment conversion fails to occur automatically. So it won't do it automatically. And let's look at how we're going to see this run out. We might have some loss of information here. Let's do this first one. We have long big number with a good sized number in there. And we're going to take that big number and try to put it into an integer called small number. And let's see what happens. Because we have all this value here. It should not fit. Because remember, integers are negative to positive 2 billion. So we've got there. So right in this area here, we are in the millions here. So in the billions are right here. So we should not see all of this information. Let's try that here. Okay, so it's not allowing that at this particular time. As we can see, a big number here is actually being used at that point in time and up here previously. So let's change our variable. And it doesn't look like it's going to fit because it's wanting to put big number into a long scenario. So it's not fitting in that direction there, as you can see that it. Now if we were to try to change that, we could maybe cast it as a long, and we should be fine because it will house that information. It will not naturally do that. You can't convert that. So we can do a long there. Now let's actually try this here a little bit different. I'm going to make that an int still, and I'm going to cast this to an int. We're going to force it to do this, and we're going to see if we lose some information here. I'm imagining we're going to lose a little bit of some information here. So big number comes back. Like I said, it only goes to positive and negative 2 billion. So 2 billion and some change. So this is what's happening. It said its upper parameter and its upper limit there. So that integer can't hold that long value. So we're going to lose some information. That's important to note. All right, casting. We can explicitly force narrowing conversions by casting data to different type. We saw that just as an actor or actress is casted in a movie as a character, the data being cast does not become the type. It just behaves as the type. For instance, Felicity Jones is cast as Jyn Erso in Rogue One. So we can explicitly force that promotion in casting. We've done that here with our Num Cookies example. So when we're playing around with this, knowing that if these are integers and we do integer division, we can lose some information when our decimals are not recognized. So let's fiddle around with that real quick. So we have int, this is a refresher. And then let's say okay, num friends. Oh, I just spelled friends right there. So let's see if that picks that up. Okay, num friends. Let's run this now. Okay. We are going to be getting our 2.0 cookies here simply because when you divide 12 by 5, it goes in there 2.4 times. But since integers don't house or hold decimal values, you lose that 0.4 of a cookie. And we talked about that. So we need to make sure that we are forcing promotion over here by saying this is as well a double, so that I don't want to lose that information. Now I have my 2.4. Okay, so we have now forced that casting and promotion to take place. Casting limitations. Not all types can be cast as different types. So following these green arrows representing valid conversions that can be forced with a cast. So a double can be put into a character, an int and a long. A long can go to a character and int. It can't do a double. And an int can only be put into, forced into a char for casting. Okay, which of these is going to be valid? And we can code these out and we can see which are not going to be valid. Let's see what we have here. First, this string amount. That doesn't look right. But let's test it out nonetheless. This here has a decimal place in that, and I'm not sure that an integer will hold that. This looks like it would work, but I think we're going to lose some values over here. I think we'll lose that 0.23. And this is, once we have identified what Boolean, what type of variable this is, we don't need to recast that. I don't believe you can cast that again. So let's code these out and just see what we got here. Okay. Okay, it is not liking string amount. We can't, that does not work at all. Okay, so we can't do that as we had thought. Cannot cast from an int to a string. So it does not work that way. So we can't use that villain. Okay. Second one, like we talked about, an integer only holds whole numbers. So what we have here is the problem of that decimal point being lost that information. It's saying we needed to either cast the result as a double or add cast to the int, and that's going to then lose some information there. So the best way to do that would be to cast the result as a double, so that we would be able to keep that 3.4, the 0.467. We run like this, it's going to lose this 0.467. We will lose that. It will take that away from us. So we would like to, that doesn't work there. Okay, same thing going on here. We have cast this 56.23 into an integer. I'm going to show this to you here. We're going to run this here, and I'm going to imagine we are going to cancel. We have some errors here, so I'm going to comment these out. Now run that again. Like we said, 56, we are going to lose that 0.23 because you can't house decimal points in an integer. Next one is double pi. We'll go to count. Looks like we could try that. I'm going to print out pi. Now pi is, in this particular case, not going to be the value. It's just a variable name. So that might be somewhat confusing. We can change that here soon. So pi is 56. So see, that's not, we're moving that around. Now what we could do here is to, if we wanted to have pi have that value there, I could come back up in here and I could say, we could change this around a little bit to put this as a double. Now we're going to hold that value in pi and count, and it should move it in here to pi. So we should see that decimal place in both of these values down here. So we now keep that by changing that around here. Okay, what we have here is that we cannot cast from string to Boolean. So this is a string right here, and you're trying to cast a string in that particular aspect. So the best way to type this one out is just to tell the value of is true. So it would look more like this. Just to say that it equals true at this point. That would be how you would do that. And it says that I already used that variable there. So if this one wasn't active, then that would be just fine. Okay. Promotion, conversions, and expressions. So when an operator applies promotion to a pair of operands, each of which must denote the value that is convertible to a numeric type, the following rules apply. So operators are either side of the equal sign. Operands are the individual numbers or different things that are going to be added, subtracted, divided on each side of the equal sign. So an operand is going to be the numbers, like say for instance if you had an equation, x equals 3 plus 5, x and the 3.5 are going to be operators, whereas the 3 plus 5, 3 and 5 are operands. Okay, so either operand is of type double, the other is converted to a double. So we saw that right here. In this particular case, num friends is an integer, but when we cast num cookies to a double, both sides become a double. If either operand is of type float, the other is converted to float. Same thing there in long, long, and then otherwise both operands are converted to integers. So again, you only need to convert one. In this particular case, one operand, and it will evaluate the entire operator on that side. So let's do an example here. When multiple data types are used in an expression, promotion happens automatically. So when we have, so sum is a double that we've assigned as a double. Count is going to be promoted to a double as well. So that will work just fine here in that case. Let's code that up real quick and see what that looks like. Now I've used count up here before, so I need to rename my variable. I'm just going to put count 1. And then I'm going to print out that average. .5. Okay, so that works pretty well. You can see here that now my conversions work just fine, and I'm printing out average as a double. So if we can think about 10.5 divided by 3, make sure that works out. 3.5. That's what we should expect. Promotion and expressions, some pitfalls. When only integer data types are used in an expression, the result will be an integer. There's nothing to promote. So in this particular case, on the right hand, the operands on the right hand side are both going to be integers. So this is where you're going to see some problems with integer division. So if we look at this here, I'm going to code this up, and you'll see that we're going to have an issue here with integer division. So I have a sum, int sum. I think I have one of those already. Let's see, equals 10. And then we have a count, and that equals, let's say, 3. And then we're going to get an average. Now I need to add in some things here. So let's see, sum 2, count 2, average 2. Looks like all those are fine. So let's run this out here. Right now we have 3.0. Okay, so when you get 10 divided by 3, it is not going to be a 3.0 in even division there. So I have 10 divided by 3. It's 3.333. Now the problem is, when I evaluate this side here, integer division will only hold that whole value. So when I do 10 divided by 3 and it comes up with 3.33, it drops that decimal point. So all I get is 3, and that gets sent over here to this double average 2. So the value now for average 2 is simply a 3. We lost some data there. So you do need to worry about this as an issue with integer division, that you can lose that decimal point, those non-whole numbers. So that's a big concern. Make sure that you watch out for integer divisions. How can you fix this? Well, we can cast. Make sure that we cast one of these as a double. Now then, when that 3.0 average, which should come up to 3.33333. Okay, that's how you can fix that. So that's it. How will we fix that? Okay, order of operations. This is exactly what we're talking about. We need to recall that expressions are evaluated from left to right in order of operator precedence. The order can change results of an expression, especially where integer division is involved. So this is a pretty good question. Does volume 1 equal volume 2? Well, let's run this, and we'll see. And let's just test this out on a calculator real quick. So, okay, radius is just 1, so we're whatever we have times by 1. pi is going to be 3.14159. So I'm going to start with this first one here. 4 divided by 3, because you order of operations, you do, remember, so parentheses, I don't see any parentheses, then we're going to do multiplication and division from left to right. So first we take on this division problem, then we multiply it, and etc. So we're going to take 4 divided by 3 is equal to that times 3.14159 is 4.18. So that's what we got for that first one. Let's clear that. Let's see, pi, 3.14159 times radius cubed, which is 1, so don't worry about that, times 4 is equal to that, divided by 3 now, 4.18. Oh, they are the same. They are the same. However, there is an issue here. There is an issue with integer division. So let's code these up and see if we get the same answer. Maybe Eclipse will catch this for us. Four divided by 3 times pi times radius. And then we also are going to do another one. I have to name it 2 so that it works. It's pi times radius cubed times 4 divided by 3. Alright, and now I'm going to print these out. Okay, so when we did the math, we came up with, they were both 4.18. Now let's run this here. Oh my goodness, we are seeing an issue here that didn't come out the way that we anticipated. So, going back to volume 1, which is this right here, we need to look at this. There is that integer division issue. So instead, this actually looks like this. So we have 4 divided by 3, and that actually is equal to 1 because integers don't hold in, these are integer values, 4 and 3 are integers, so that holds 1. 1 times 3.14159 is that value there, so that's how come we get that down here. Now, if we were to force some things here to make this work, we would say that maybe one of these is a double in order for that to calculate correctly. But that's how come that integer division is failing there. So 1, 3.1. So that's why we're getting this value here. Cool. So be aware of issues with integer division for sure. Okay, here's an assignment we're going to be working on. It's a temperature converter. So let's look at this program here. We have a public class temp converter with the main method. Here is our formula for converting Fahrenheit to Celsius or Celsius to Fahrenheit. Computes the Fahrenheit equivalent of a specific Celsius value using the formula. Fahrenheit is equal to 9/5 times Celsius plus 32. Okay, so then we come back in here. So we have our base of 32, a double Fahrenheit temp value, nothing stored in there yet, and an int Celsius temp of 24. So this is an integer, this is an integer. All of these are integers on this side here. If we look at that, Celsius temp is an integer, and base is an integer. So the problem here I'm thinking is that if we're having a bunch of integers trying to put them into a double, we're going to have an issue with this converter. So we need to, let's program that out. Let's see if we can have one I pull up a temp converter. I think I've done these already, so let's take a look at what I have here. I did add a few things in here to make this a little bit. I'm going to pause this and reorganize this first. Okay, I'm going to create just a new class. I'm going to call it temp converter. That way I can just mess around in here and add a main method. So we're going to create a new class that I can fiddle around with the examples on. So, okay, I'm gonna grab this. I think I actually could maybe take it right from here. Maybe not. Nope, I cannot. All right, so I need to create a public class. Temp converter did that. Main method. You put in there. We've got a base 32 double Fahrenheit in Celsius temp. Okay, let me get that set up. Double Fahrenheit temp. In Celsius temp 24. All right, so Fahrenheit is equal to Celsius times 9 divided by 5. Maybe that's it. Okay, let's run this here. Fahrenheit temp is 75 degrees. Now, I'm thinking there may be an issue. Let's just take a look at this because we have, like we said, this Fahrenheit temp is a double. I'm going to just see if I can cast this as a double and change that 75. Let's see what happens when I do that. Okay, I do get that point too. So what we would want, as we were referring to this here, it'll work. Will the temp converter program produce an accurate conversion? I would say sometimes. Sometimes it would. If the value happened to be an even division where they didn't use any decimal points, then it would be accurate. Otherwise, it's not, because you would lose that small percentage. But I'm sure there are going to be situations where it's going to be, it would work if it was just like 75 degrees, but it doesn't for this particular case accuracy. We did this last time, so this is a review. Assignment operators is common for the right-hand side and left-hand side of an expression to contain the same variable. So in this particular, count is equal to count minus 1. So again, you evaluate the right-hand side first prior to the evaluation of what comes on the left-hand side. So we would take whatever count is, u minus 1, and then reassign it to the value count. Now there is shorthand ways of doing that. Count minus equals 1 is the same as count is equal to count minus 1. We did that last time. So this is the shorthand assignment operators. Increments, it's the same as saying count is equal to count plus 1. So when you see a plus plus, if count is 10, count plus plus is going to be count plus 1, so that would make it 11. So count after evaluating this line here, count's new value would be 11. Same thing for the decrement operator. That minus minus is the same thing as saying count is equal to count minus 1. So if we start off at 10, we do count minus minus. Following that will be 9. We did this example in our last one. So some things to be looking at for our review. Make sure that you know about widening and narrowing conversions, the automatic assignment conversions, casting, promotion, the assignment operators, increment and decrement operators. Make sure you know all those. Okay, here's an activity. I want you to read through this activity, and then we're going to pause, and I want you to work out the coding on your own, and then pick up the video after you're done to see the solution. So right here, we're going to have this after we've gone through, you should be able to write a program that uses various data types and expressions to produce accurate results. So we're going to write a program that calculates how many cans of paint it would take to paint a square room with rectangular walls. One wall has a door on it, and there are no windows. The dimensions of the wall are 12 foot by 15 foot, and the door is an 8 foot high by 4 foot wide. So each gallon of paint can cover 400 square feet. How many gallons will it take? Okay, be a good chance to pause the video so that you can then code this up in your Eclipse, and I'll see you back here in a second. Okay, so you've had a chance to code that up. Let's take a look at how we can solve this. I'm going to create a new class called Paint the Room. And in here I'm going to put a main method in. And let's see what we can do here. So we have our problem. We're going to paint a room. We have some information that we can put in. So we know that we have 400 gallons of paint. So we'll see how that's going to work. Maybe I want to use double as much as I can, because I know that I would like to not worry about having, I want to make sure I have enough paint. So if it comes out that I have need 4.5 gallons, but I don't do my appropriate assignment of my variables, I might be coming out with needing only 4 and come up a half a gallon short. So I want to make sure that we can do this. So first off, I think that I need to kind of think about what variables I need. So let's see, gallons, I don't know, but that's 400 because that's what we have. I don't think we're going to, because it says here we have each gallon of paint can cover 400 square feet. So 1 gallon will cover 400 square feet. I don't think I need 1 gallon, but double gallon. Okay, so then we have our height of our rooms, and those are going to be 12 feet. And our width of our rooms are going to be 15 feet. And we do have a door in there. So the value of the door is, it's an 8 by 4 door. So then let's do a volume. So double door volume is equal to 8 times 4. So then that's the volume of the door. Total volume, we need to make a double for that to hold this. So this way we'll know totally what we'll need. So let's say we're going to take our so we have 4 rooms, 4 walls, but we have to minus the door out of one of the walls. And we have figured out that the door's volume is an 8 by 4, so we have 4 rooms of height and width. I'm going to do this for height and width, and we're just going to minus out the door volume. And that should give me how much volume, but now then I need to divide that up and figure out how many gallons I'm going to need. So I'm going to say gallons is equal to volume So now that I have my total volume, and it said here that each gallon can paint 400 square feet, so this is going to be, I don't really know if this, I would say area is probably better for what I'm saying here. Total door area, let's change this around. Area, total area, I like the way that we like this better. Now I'm going to show something here to you. Control Z. Okay, so I'm going to go in here and I'm going to change this variable. I'm going to refactor it. I'm going to rename it. I'm going to name it door area. And it is going to adjust that wherever it is found in my code. So I like that it does that. And I'm going to refactor this one too as well. Refactor. Rename. And I'm going to do this total area. That's going to be nice. So area divided by 400 square feet. So this is total area in square feet, because these are all in feet. Each gallon will paint 400 square feet. So we should be able to print out how many gallons we need. Let's see what happens here. 1.72 gallons to get this all done. Okay, so that's a cool little program that we can create. And again, good thing that we know about taking that double value. Otherwise, we would lose. We would come back with 1 gallon of paint, and we wouldn't have enough to get our project done. Okay. So that's the end of this PowerPoint presentation. Thank you for watching.